Hello friends, today we are continuing on set theory. In this video we'll learn about set operations. Okay, what are the set operations? Now there are basically three types of set operation. So for that, let A and B be two sets. Okay, then first operation is called union. Okay, what is this? It is denoted by A union B, and what it means? It means all the x such that x is either belongs to A or x belongs to B. Okay, so number two, the operation is intersection. What is this intersection means? It is denoted by A intersection B. This is the symbol of intersection. Okay, what does it means? All the x says that x belongs to A and x belongs to B. Okay, now what is the third operation? Third operation is difference. What is difference means? It is denoted by A difference B. Okay, what is this? This is all the x such that x belongs to A and x does not belongs to B. Okay, these are the three operations. Now if you try to understand this through diagram, in set theory diagram we means Venn diagram. Okay, in set theory diagram means Venn diagram. So for union, if this is the universal set, okay, U, this is A and this is your B, then the union can be A union B. If this is the Venn diagram for A union B, it means everything within A and B. Okay, if something is repeated like this portion is repeated, so we express this element just once. For intersection, if this is your A and this is your B, then this portion is called the point portion of intersection. This is A intersection B, means all the common elements between A and B. If there is no common element, suppose if this is A and this is B, okay, so there is no common element, then A intersection B is empty. Clear? So this is the thing. Now what about difference? For difference, what is the Venn diagram? If this is A and this is B, what is A difference B? It is just the portions of A. Okay, not this common part. You exclude this common part. Similarly for B difference A, we include only this B portion, not this common part. Okay, exclude A, also the common parts with A. Fine. So one thing you can see from this also, that A difference B is certainly not equal to B difference A. Okay, now we go through few examples. See, A is equal to A B C, B is equal to B C D, then A union B is A, B, C, D. Okay, and we count everything, whatever is there in A and B. Suppose D is either A or B, so it is in B, so we include. A is in A, not in B, but still it is in A, so A or B means it is in A. For intersection, you can see there are two common elements, B and C, so we include B and C. Okay, for the difference, you see A difference B means you exclude all the elements of B from A. So if in B we have common BC, so exclude BC, so this is singleton A. Similarly, B intersection A is nothing but D. Okay, got the point? Fine. Another is there, that is symmetric difference. These are all binary operation. In another video I will explain about unary operation and few properties of set operations. I don't want that these videos are too long so that you feel bored. Okay, this is A, this triangle is for symmetric difference. B is nothing but all the x, or you can say not to this, simply A difference, because you know the meaning of A difference, B and B difference. A difference B union B difference A. If I explain this diagrammatically, this is your A, this is your B. So symmetric difference represents this portion. Okay, it excludes this common part. So if I say example wise, so this is nothing but this, we have in our example, this is A union. So we have already this part, this portion is this one and this portion is this one. So if I take union of these two, this is AD. So this is called symmetric difference. So with that I am ending this video. Okay, thank you.